Hey developers, today we are creating a column chart with SciChart.js in React. Perfect for categorical data, sales metrics, survive results and any category comparisons. We will add the data labels, rounded corners, gradient fields and animations. In the end, you will get the production-ready chart with WebGL performance. Let's look at the project structure and start with the React component. We see two files, index.tsx, this is a React component, and drawExample.ts, this is chart creation logic. Let's open the index.tsx file. This is the entry point for displaying the chart. The library provides a special SciChart React component that automatically manages the lifecycle. Let me explain what's happening here. SciChart React, this is a wrapper component, manages the chart lifecycle. It handles mounting and unmounting automatically, so we don't need to write this code yourself. In its chart, we pass the initialization function as a prop. This function runs when the component mounts, creating the chart. When the component unmounts, SciChart React automatically calls the delete method to free up WebAssembly memory. This prevents memory leaks without any extra work for you. Now let's look at the drawExample.ts file to see how the chart is created. Most of the code is commented out, so I can show you step by step how everything works. At the beginning, we see imports. Import the necessary components from SciChart. Don't worry, we'll go through each one individually later, when we will use them in the code. Right now, it's only important to understand that FastSeries, this is a WebGL accelerated versions, always use them for a better performance. Modifiers add interactivity with literally one line of the code, so make sure to use them in your project. Now let's move to the drawExample function. This is an async function that creates and configures the chart. We create the chart surface, and this is the foundation where everything is rendered. The create method is async because it allows WebAssembly modules in the background. So let's focus on the key points. SciChart surface, this is the main chart object where everything is rendered. We will use it to add axes, series and modifiers. Wasm context, this is WebAssembly context, will be passed to all SciChart components and it manages memory and ensures performance. That's why SciChart is so fast. Theme, here we pass our styles that define how colors like vivid orange, vivid sky blue, pale sky blue will look. This way we can customize the appearance of the chart and use the same theme across all charts for consistency. Let's see what we got. Look at the browser on the right side. We see an empty surface with the theme applied. Nothing is displayed yet, but the foundation is ready. Now let's add axes to see the coordinate system. Let's continue writing the code. Axes define the coordinate system. We use numeric axis component, which we imported at the beginning. Let me point out a few things here. We use SciChart surface for both X and Y to add axes to the chart surface. Label precision removes decimal places, shows only whole numbers. Grow by new number range, this adds 10% padding at the top above the maximum value, so the tallest column doesn't touch the edge of the chart. Looks much more professional, small detail but big difference in the visuals. This is the result. Look at the browser. Great. In the browser we will see the coordinate system. X and Y axes are displayed. No data yet, but the coordinate system is ready, so let's add the data. Now let's prepare the data. In a real application it would come from API. Here we will use a static example for demonstration. We see two arrays, X values, indices from 0 to 19, and Y values, corresponding values. XyDataSeries component will combine them into XY pairs. The series supports append, insert, remove methods for real-time updates, perfect for live dashboards. Now for the interesting part, let's create the columns themselves. After adding the series, we will use the basic columns. It's time to create column series. We use FastColumnRenderableSeries, the WebGL accelerated version we imported. We see Wasm context again here, and we create XyDataSeries with our data. We attach the data to the series. Let's see what we got. Look at the browser. Great. In the browser, we see columns. They are already displaying, but there's not any style. Now let's set styling. Look at the code. Looking at the styling field with edit 77, this is a hex code for 47 opacity. Semi-transparent, columns look modern. Stroke defines the border color around each column. Stroke thickness, set the border width to 2 pixels. Data point width, each column takes 70% of space between X values and the remaining 30% creates gaps. Cordon radius rounds the top corners of the columns. Let's see the result. Look at the browser. Much better. In the browser we see that columns are now semi-transparent, rounded with gaps. Let's add the data labels. Look at the code. Data labels display the exact values above each column. Let's break down the configuration. First of all, horizontal text position center and vertical text position above. This position the label centered horizontally and placed above the column. Thickness, this is our thickness import in action. The parameters represent padding, top, right, bottom and left. We're adding 8 pixels at the bottom to create space between the label and the column. Precision, this ensures we display only the whole numbers with no decimal places. Let's see how labels look. Look at the browser. Perfect. In the browser we see that now exact values are displayed about each column. This improves readability. Let's add appearance animation. Look at the code. Okay, let's add animation. We use the WaveAnimation component. Another one of our imports animates column appearance smoothly from bottom to top over 1 second. Let's refresh the browser page to see the animation. The columns appear from bottom to top. The animation is complete. Now the most interesting part is gradient fill. Look at the code. This is where our palette factory gradient params and point imports are used. First of all, palette factory creates the gradient for each column individually. Let's break down parameters. First of all, gradient params. This is a diagonal gradient from bottom left to top right. Offset, this is a color position gradient from 0 to 1. Here orange at bottom, sky blue in middle and teal at the top. Palette provider overrides simple fill and opens possibility to dynamic coloring. Why not just use fill with gradient? Palette provider allows changing color based on the data values, creating heat maps, or implementing your own coloring logic. Let's see the final result with gradient. Look at the browser. Whoa. In the browser we see that now each column has a beautiful gradient, from orange to the teal. The chart looks professional. So now let's add interactivity. Look at the code. The chart looks great, but it's still static. Let's add interactivity using modifiers we imported at the beginning. We already have a few modifiers and let's start from the beginning. The first one is zoom pan modifier. This allows you to drag with the mouse to pan and select the rectangle to zoom. Zoom extends modifier adds a button in the toolbar to reset a view. Mouse wheel zoom modifier, zoom with the mouse wheel, similar to Google Maps. Zoom extends feeds the view to all data on the first display. We return an object with surface and context needed by the React component for proper memory cleanup on unmount. And what I can say, everything works smoothly, even the thousands of points, thanks to GPU acceleration. Let's try it right now and look at the browser. And we are done. We created a column chart with gradient fill palette provider. Each column has its own gradient. Data labels above each column. Appearance animation on first load. Full interactivity like a zoom in, pan in, and high WebGL performance. It's important to remember that XyDataSeries component supports real-time updates with append, insert, and remove methods. This same pattern works for any other SciChart chart types. In the end, if you want to dive deeper into SciChart capabilities, links to documentation and examples will be in the description below the video. Thanks for the watching and happy coding.